What is the oxidation number of carbon in the following compounds? C3H8O4. Well, I can at least do the problem correctly, and then we can fix it. For the last one, and hopefully this one's correct. This time, the key is oxygen in compounds is always -2. Hydrogen in compounds is always +1. In this particular compound, I have 0 charge, so the whole thing has to equal 0. And -2 times 4 is -8. +1 times 8 is +8. So depending upon how you do it, sometimes I like to put x in here. Sometimes I can do the math anyway. This one's pretty easy because x +8 -8 equals 0. You can see these two parts cancel out. X equals 0. And then if the total oxidation is 0, the way that you find the number that is the oxidation number on each carbon is your total ox divided by the number of carbons. So 0 divided by 3 is still 0. Let's go see if we can put that in. Well, and we can definitely put it in. Let's see if it marks me right. So far, so good. So
explain that one again for me.
It would be my pleasure. So you see that the right answer is 0, right?
Yeah, I'm not understanding like how you do the chart and everything.
Sure. Let me try it again. So I'll take a new piece of paper. Because sometimes for me, whenever I start a problem, it helps me to start over again. Okay, so this is my basic setup. There are lots of ways to do oxidation numbers, and all of them are fine with me. Of course, if you do it for me and I ask to see your process, you'll have to show me something. So this one, so the rules from the lecture outlines say that the oxidation number for oxygen in any compound is -2. Are you okay with that? Or would you like me to say more about that? I'm sorry, I can't hear you. Feel free to type in the chat because I think there's some audio.
I'm good on that, I'm sorry.
You're good on that. Okay, good. Okay, and just to be clear, just to show you separate cases, so O2 here, this is oxygen by itself. And another rule says that anytime any element is by itself, including oxygen, its oxidation number equals 0. Okay, so this is oxygen by itself. This is oxygen in a compound. All right, we have another rule that says hydrogen is +1. And all I'm doing here is to get what I'm calling the total oxidation. And again, this is just totally something I made up to help my students. You won't, question, was this exercise on the homework? Yes. This was, I think, O2-19. So the total ox is the oxidation number times the subscript. Oxidation number times subscript. So -2 times 4 is -8. +1 times 8 is +8. And then the next thing we say is, if there's a charge, it's going to be up here somewhere. With no charge, there's nothing there, so we set this equal to 0. And what we can do is, we can try another one of these if you want to after this, because it is a little strange that it works out to 0. But you're going to put a number here that makes this math statement true. So whatever this number is, +8, -8, it has to equal 0. Mathematically, you can think that these two cancel out and x equals 0. Any questions about that? Okay.
I'm good. I'm good.
And so, right, great. And if it's 0 here, then the number that goes in this box is whatever's down here divided by 3. It's like like we're going down, it's this times this. When we go back up, it's this divided by the 3 equals the oxidation number. So oxidation number for carbon equals total ox divided by number of carbons, which is 0 divided by 3, which is 0. So, any questions about that? And would you like to see another example?
I'm good. I have a question. Was lecture 2 due yesterday?
Yes, it was.
What?
Should have been.
Cause I thought it was due today. I'm not sure. Like I kind of still don't know the schedule a little bit. So.
Well, let's go take a look. So let's get out of here. So if we go back to course content, we're in week number 2 now. Oh, am I recording? I guess I can stop recording that now.